So today I'm going to be talking a little bit about the long-term changes in water quality in the U.S. and some of the ways that societal needs and societal perceptions have changed, and as a result, some of the societal responses to this have changed as well. Okay, so I'm calling this talk "Water Quality Evolution from Industrialization to the Age of the Internet." And the talk is going to be broken up into two main parts, where in the beginning I'll be talking about these long-term changes and these very broad-scale changes in water quality in the U.S. and how we've responded to them. And then the second part of the talk will be about some more empirical data that we have published recently, looking at nitrate concentration trends during the late part of the 20th century. I would like to acknowledge the USGS NACWA Century of Trends project that funded the majority of this work. That project ended in 2013, and a lot of the surface water trends analysis is now being done under the USGS NACWA Cycle 3 Surface Water Trends team, which is being led by Lori Sprague. I'd like to also thank some of my colleagues that worked on the Century of Trends with me, including Valerie Kelly, Whitney Broussard, Thor Smith, and Charlie Crawford. Donna Myers has been sort of a long time, has had a long-standing interest in these long-term analyses of water quality, and was a great advocate for the Century of Trends project. And also thank Lori Sprague, who is, as I mentioned, leading the current Cycle 3 Surface Water Trends team. So when I give talks about this subject, I like to start with this picture, okay? And this is an artist's depiction of the Schuylkill River from 1868, okay? So that's getting close to, about 150 years ago. And the thing that I like about this picture is that I think it demonstrates that, water quality problems have existed in the United States for a very long period of time. This is showing something called the Schuylkill Ship's Works. And even though it's just an artist's depiction, I think it kind of brings home this point that even 150 years ago, there were places in the United States where there were fairly significant anthropogenic impacts on rivers, and that was coupled with very lax rules in terms of the kinds of things that could be dumped into rivers, and along with that, sort of air quality and everything else. And so, water quality is something that has been causing, potential problems for a very long period of time, okay? And so that begs the question of when water quality problems really began. And one point I'd like to get across today in this talk is that increased usage of water leads to increased degradation overall, okay? And one great way to increase water usage is to make it more available, okay? And the way to make it more available is to build public waterworks. The first public waterworks was built in the United States in 1802 in Philadelphia. By the middle part of the 19th century, there were more than 100 public water utilities, and there were over 600 by the end of the 19th century, okay? This increase in water availability also resulted in increased water usage, okay? And this was really the beginning of widespread water quality degradation problems in the United States, okay? And part of the reason this happened is that the wastewater infrastructure in the United States in the 19th century was an extremely informal system, okay? There tended to be sort of cesspools and sinkholes in populated areas where wastewater was dumped, okay? That water was then either just sort of left there and soaked into the ground, or it was emptied under contract and taken to nearby streams and rivers and dumped out. And sometimes it was also spread on farm fields as well, okay? But as water usage increased and the amount of wastewater generated increased at the same time, these informal systems got overwhelmed pretty quickly, and it caused some really unpleasant conditions in populated areas, okay? And this was really the first impetus to build sewage systems in the United States. And these sewage systems, the 19th century sewage systems, were really just conduits that took wastewater away from populated areas and transported them as quickly as possible into nearby streams and rivers, okay? And there wasn't really any thought given to treating any of this wastewater. And this situation was blamed for a series of waterborne disease outbreaks in the late 19th and early 20th century, okay? So I'll just give a couple of examples from that time period. And just to let you know, I'll be thinking about water quality changes in the U.S. under these sort of very broad eras, okay? There again, the beginnings of water quality problems in the U.S. really were in the late 19th and early 20th century. And that spurred something called the water sanitation era, which is really focused on addressing the human health issues surrounding water quality problems in the U.S. In the middle part of the 20th century, there was really a change in the way pollution manifested itself in U.S. rivers, okay? And it was moving away from sort of a strictly human waste, human health kind of a problem, and became more about things like eutrophication, the appearance of these sort of exotic organic chemicals as a result of the chemical industry in the United States. And that was really the beginning of, I think, what you might think of as the modern water quality problems in the U.S. These problems were addressed to some extent by the Clean Water Act, which was passed in 1972. And since then, we've had, lots of progress and some continuing problems in that arena as well. And I'll try to touch on each of these today a little bit. Okay, so I'm just going to go through this example quickly of a water quality problem from the 19th century and a response to it, okay? And this comes from Chicago, and it's the building of the Chicago Sanitary and Ship Canal, okay? So Chicago, as you may know, is located on the banks of Lake Michigan. Lake Michigan serves, in the 19th century, Lake Michigan served as both the wastewater receptacle from Chicago as well as the drinking water intake, okay? And so the Calumet and Chicago rivers, which are located in Chicago, drained the city of Chicago's wastewater into Lake Michigan. The drinking water intake for Chicago was also in Lake Michigan, although it was located up current from these longshore currents that exist in Lake Michigan. And so most of the time, the water that was being withdrawn from Lake Michigan was relatively clean water, and it was usable by the people in Chicago. But on occasion, you would get mixing of these two water bodies through, storms and things like this, and occasionally some wastewater would get sucked into the water intakes, and as a result of this, there were repeated cholera and typhoid fever outbreaks in Chicago in the late 19th century. Okay, and this was linked to contamination of source waters in Lake Michigan. So the response by Chicago was to divert the Chicago and Calumet rivers away from Lake Michigan and into the Des Plaines River by means of the Chicago Sanitary and Ship Canal, okay? The Des Plaines River is not in the Great Lakes Basin, but is in the Mississippi River Basin. And so they essentially changed the basin structure of the Chicago and Calumet rivers. And they built these control structures on the rivers as well to control the amount of water that was drained out of Lake Michigan. And this was used to essentially dilute the polluted wastewater that then began running down the Des Plaines River, okay? Now, this type of, and so if you look at a map of the watershed of the Illinois River today, it has this funny shape where it comes up and sort of hugs the coast of Lake Michigan. And the reason for that is the diversion of those two rivers away from Lake Michigan and into the Illinois River Basin. Now, that story, I think, brings home some really salient points. Okay, first of all, wastewater or water quality problems were manifesting themselves primarily as human health problems in those days, okay? The federal government really just stayed out of it, and it was considered to be really just a local problem, okay? The federal government was really just focused on protecting navigation in those days, and not so much on water quality, or not really on water quality at all, okay? But the states, on the other hand, were closer to the front lines in this public health crisis that was developing, and so they formed these public health boards that were intended to induce better wastewater management within the states, okay? In practice, very little was actually done to treat wastewater, and the focus instead was on treating drinking water to combat waterborne illnesses, okay? And an example of this comes from Pittsburgh in the early 20th century. Pittsburgh in those days was really the industrial hub of the United States, and it produced a tremendous amount of wastewater, which went untreated into the Ohio River, and started to cause problems for downstream communities. The Pennsylvania Public Health Board tried to force Pittsburgh into treating its wastewater. the city engineers and city economists for Pittsburgh came back with a study that basically said it would be much cheaper to treat the drinking water for downstream communities than it would be for Pittsburgh to try to treat its wastewater. And so they were issued a permit that allowed them to continue dumping untreated wastewater into the Ohio River, and that permit remained in effect into the 1930s, okay? So this is the kind of cost-benefit analysis that was going on in those days. So the situation, the way you could think of it in those days is, you have some sort of a populated area. There's a source water that, let's say it's a river or something that runs near the city. Some of that water is diverted out of the river and into the city to be used for municipal purposes, and it exits the city as wastewater and often just returns right into the source water, okay? By the early part of the 20th century, these source waters were becoming polluted, which meant that the drinking water going into the cities was polluted as well, and of course the wastewater coming out was certainly polluted in those days. The water sanitation era, which was these first couple of decades of the 20th century, really focused on treating the drinking water in these cities and did not concern itself at all with treating wastewater streams, and then by definition also did not concern itself with treating source waters at all. And part of the reason for this was that there was a belief that streams had the ability to purify themselves from pollutants. And so you find a lot of publications from that time period with some different take on this phrase of self-purification of streams, okay? And so, this is really, it's sort of basic biogeochemistry. I mean, streams really can rid themselves of pollution given enough time and given enough river miles. But the simple fact was that any capacity that most streams had to purify themselves was being overwhelmed by the early part of the 20th century. And the result were these public health crises that kept popping up in those days. This is a table I came across in some of the background studying I was doing for this project. And this comes from, I don't know how well you can read this, but this comes from a study on the Ohio River, and they were looking at typhoid fever death rates in these two cities, Cincinnati and Louisville, Kentucky, before and after drinking water filtration. Cincinnati had a typhoid fever death rate of 64 people per 100,000, and Louisville was a little bit lower in the 50s per 100,000, okay? So I live in the Denver metro area. The population of this area is about 3 million people. So if we scale that to today's standards, that means in the Denver metro area, you'd be experiencing 1,500 to 1,800 deaths from typhoid fever every single year, okay? And that does not even count the people that, end up in the hospital and then recover, people that get sick and miss days of work, people that have long-term problems arising from typhoid fever. And so this was really, it was a very real problem. I would be willing to bet that if you lived in one of these two cities back in those days, you would probably know somebody that died from typhoid fever. And so this was a very real public health crisis at that time. Now, during the water sanitation era, the focus was really on addressing this particular problem. This is a figure from the CDC and shows just how sort of remarkably successful that particular program was. So this is showing typhoid fever death rates from the beginning of the 20th century throughout the United States. Again, a relatively high death rate overall. But by the middle part of the 20th century, it was essentially unheard of for somebody in the United States to die from typhoid fever. And it was because of this focus on cleaning up the drinking water supply for populated areas in the United States. Okay, so it was a very successful program overall. Now, during this period, there were some other developments that I found fairly interesting. And these were sort of going on outside of maybe the political arena, and so they weren't the overall policy focus at the time. But they were these really interesting, I think, intellectual developments happening. First of all, there were changing perceptions about the nature of water quality problems, and a recognition that these problems tended to be regional rather than strictly local problems. And this was really codified in the Public Health Service Act of 1912, which created the U.S. Public Health Service and gave that particular agency the authority to conduct public health surveys of rivers that cross state lines. And so some of these early, very famous studies on the Ohio River and the Potomac River came out of this Public Health Service Act of 1912. It sort of I think, embody this idea that there was a growing perception that water quality problems could cross political lines. There's also some interesting studies going on by the U.S. Fish Service, which was a precursor to the Fish and Wildlife Service. Okay, they were looking at freshwater mussels in freshwaters of the U.S. and finding just this, widespread demise of mussels overall. I think that's an interesting story from the early to mid part of the 20th century. And they were discovering that really, among the things that were causing these population crashes in freshwater mussels was this generation of silt from agricultural land clearing in the early 20th century, okay? And so this, I thought, was interesting because it is, they're identifying a water quality problem in those days that was not, say, strictly a human health problem and was not strictly related to human waste entering streams and causing waterborne illnesses. So it was definitely a change in that way of thinking. There's also this, some other interesting things happening in those days. The Isaac Walton League advocated very heavily for the creation of this wildlife refuge on the Upper Mississippi, okay? And I don't know how many of you are familiar with this. It's called the Upper Mississippi River Fish and Wildlife Refuge. It's essentially a riparian refuge that extends from Minnesota and Wisconsin down into Iowa and Illinois. And the kind of arguments that were being used by the Isaac Walton League in those days were very interesting, I thought. And they were arguing that you should protect these riparian areas because it'll help control flooding and it'll help with sediment problems for downstream communities in this particular area, okay? And I thought that was fairly interesting because, I feel like we're still having these arguments today over these kinds of issues, and here it is 90 years later, okay? And this was first being discussed way back in 1924 by the Isaac Walton League. At the same time, other pollution problems were continuing to worsen. Internal combustion engines were becoming more popular. This led to greater oil usage in the United States, and as a result, there were more oil spills within U.S. rivers. This era also saw really the rise of BOD problems in U.S. rivers, okay? And this caused low oxygen or high ammonium in U.S. rivers due to organic inputs, mostly from municipal wastewater. And it was a problem that really plagued U.S. rivers for a better part of the 20th century. You also began to see these tensions between navigation, the priority set for navigation, and the priority set for water quality in certain areas. And probably this was the most evident in the Upper Mississippi River, where the creation of the Upper Mississippi Navigational Channel caused, or really exacerbated a lot of the pollution problems that were occurring in the Upper Mississippi. Okay, and the way this worked is that during very low flow periods, these low-head dams were put into place to hold water back in the channel to allow barge traffic up to St. Paul, Minnesota. The problem was that a lot of the communities along the river were dumping untreated wastewater into the Mississippi River, and that was becoming trapped in these navigational pools and causing these really unpleasant conditions there. Okay, so moving on from the water sanitation era is this next era that I'm calling the new pollution, or like the rise of industrial waste. And really, the kinds of pollution we're beginning to see in, say, the 1930s into the 1940s was beginning to change. And this was due to a couple of reasons. One of them was this really burgeoning chemical industry within the United States that became very proficient at creating all sorts of exotic chemicals that hadn't existed before. And these chemicals and their precursors were essentially waste in a lot of cases, and wound up in U.S. rivers and created new pollution problems that were different than, I think, what had been experienced before. At the same time, U.S. involvement in World War II really dampened the appetite for new regulations on water quality, and so very little was done to create new laws during this time period, okay? I thought this was interesting, too. The U.S. Public Health Service issued guidelines for maximum allowable mercury concentrations in 1942. That strikes me as being very late in the game. I mean, people have been thinking about water quality for, probably 50 years at that point. But it probably speaks to the fact that a lot more mercury is being used overall, and it was becoming a problem in some areas. At the same time, there was a renewed interest in collecting and publishing water quality data, and the USGS began publishing annual reports on the quality of surface waters in the 1940s. Now, I'm putting the end of this era at 1948 for a couple of reasons, and one of them is because of the passage of this Water Pollution Control Act of 1948, okay? This was the first federal law that dealt with water quality in any way, and it was estimated that about 100 similar bills had been defeated in Congress over the past 46 years. This particular law was a bit convoluted, and what it did is it allowed the Surgeon General to sue a state that polluted a water body that then crossed the state line and caused some sort of an impairment in a downstream state, okay? The catch was that the state that was being sued had to consent to the lawsuit, okay? And as a result, for the 8 years that this particular law was in effect, not a single action was taken under this law. But it set a precedent that the federal government was going to be interested in water quality, whereas before it had been considered to be really just a local issue. Okay, so following on that was this, what I'm calling the growth era, this era in the middle part of the 20th century that saw really tremendous growth in a lot of different arenas in U.S. public life, okay? Among those were things like water usage, okay? So during this particular era, water usage more than doubled, okay, as population grew, as industry grew, and as water needs really grew very quickly during that time period. And if you remember back to what I said in the beginning of this talk, you know, when you increase water usage overall, you typically also find that you increase its degradation, and that was certainly happening in the middle part of the 20th century. At the same time, the U.S. population grew by about 50% over this time period. This was also the era of the Green Revolution, and this is really when we saw U.S. Agricultural fertilizer usage take off over those several decades. And at the same time, U.S. agricultural production took off as well, okay? And at the same time, these water quality problems began to emerge that had never really been experienced before, and certainly not very well understood. One of those is eutrophication, okay? And it's sort of interesting to think about this now. I think all of us have a fairly good sense of eutrophication and what it is and what causes it. But back in those days, it wasn't really understood all that well, and there were these really kind of interesting theories about why rivers were becoming eutrophied. And it wasn't until the late 1960s when Richard Vollenweider was credited with making this direct link between nutrients and eutrophication. At the same time, these drinking water treatment facilities that were built during that water sanitation era in the 1920s and 30s had reached their design ages, okay, by the 1950s. And this was kind of was a two-edged sword because, on the one hand, the facilities weren't functioning properly and tended to cause some problems. On the other hand, it provided impetus to really upgrade a lot of these facilities, and that did happen. At the same time, water shortages were beginning to develop in the U.S., and some of this was due to pollution problems. And so you see a lot of new laws being passed, especially at the state and local level, which focused on protecting water quality as a way of increasing water supply, okay? And that was really the focus of some of the rules that were being passed in those days. In terms of water quality data from those days, you know, this same story of this kind of emerging degradation of streams and rivers in the U.S. is also evident in the water quality records, okay? This comes from a study that I'll talk about a little bit later in this talk, where we were looking at trends in nitrate from 1945 to 1980, which approximately covers that growth era that I'm talking about, okay? And what we find is that nitrate concentrations were increasing in many basins around the United States. These were, you know, areas in the middle part of the country that tend to be more agricultural, places in the eastern United States that tend to be more heavily populated, and in the western United States as well. So it was really kind of a widespread phenomenon. It really speaks to this idea that water quality problems were becoming much more widespread and being caused by a variety of different influences in those days as well. There's also evidence that U.S. rivers were experiencing fairly significant acidification in those days too. Here I'm focusing on nitrate and sulfate, which are sometimes called acid anions, because the processes that lead to their emergence in rivers tend to be acidifying processes, okay? And I'm comparing mid-20th century nitrate plus sulfate concentrations in U.S. rivers compared to the early part of the 20th century. And basically, you know, almost anywhere I looked, I found that there were significantly higher nitrate plus sulfate concentrations in the middle part of the 20th century. I think another really good example of this comes from the Delaware River at Trenton, New Jersey. Again, we're comparing some different ion concentrations in the early part of the 20th century to, let's focus now on just the middle part of the 20th century. And you can see that these acid anions, nitrate plus sulfate, had increased fairly substantially by the middle part of the 20th century. And at the same time, alkalinity had been titrated out of the system fairly significantly. Okay, so this is a river that is demonstrating fairly classic signs of acidification. Okay, and this was a fairly widespread phenomenon in the U.S. In the middle part of the 20th century. Towards the end of the growth era, the President's Council on Environmental Quality issued a report on, that sort of documented the scale of the problem facing U.S. waterways. And I think that the statements that they make are fairly astonishing, and I think speak to the magnitude of the problem overall. And you can read these yourself, but these are fairly eye-raising figures. They state that the number of fish killed from pollution grew from 6 million in 1960 to 41 million in 1969. The shrimp harvest in 1965 was 0.2% of what it was in 1936, and that more than 90% of the basins that they had studied were considered to be polluted, okay? And so this speaks to really a widespread worsening of water quality in the United States, okay? And I think people knew this, and I think people recognized this, and they really wanted to try to find a good solution to this, okay? And that kind of is reflected, I think, in the activities of Congress in those days. As I said, the passage of the Water Pollution Control Act in 1948, I think, really kicked off this idea that the federal government had some role in water quality regulation. That particular law was largely ineffective, but it set in motion, I think, a larger idea that the federal government did have some responsibility to regulate some of this. That particular act was amended in 1956, and these amendments really created this state block grant system that was in place for several decades after this, and it was a way for the federal government to support state efforts to improve water quality. There also was some interesting language in these particular amendments that permitted projects to consider things like the propagation of fish, aquatic life, and wildlife when they were thinking about improving water quality, okay? And so now you see this concept of water quality as moving, I think, away from where it was in the water sanitation era, where it was solely focused on human health and on waterborne illnesses, and becoming to be more about the quality of the water within the streams themselves, okay? And this is something that I think we might recognize as being sort of modern environmentalism, but it really was not in effect in the early part of the 20th century, and you start to see it being written into some of these laws in the middle part of the 20th century. The Water Quality Act of 1965 was the first time the federal government attempted to require states to set pollution standards. And it set a regulatory authority to be in charge of this, the Federal Water Pollution Control Administration. This particular law, though, was trying to really balance the supremacy of states and the federal government in dealing with water quality problems, and as a result, the regulatory environment was ambiguous. And I think the law never really worked the way it was intended, but it did set a very important precedent, which allowed the passage of the Clean Water Act in 1972. So the Water Pollution Control Act of 1972, which we also call the Clean Water Act, was really fairly revolutionary water quality legislation in those days, okay? And it began from a very different place, I think, than those other bills that I just talked about. And it started with this stated goal that this bill is supposed to restore and maintain the chemical, physical, and biological integrity of the nation's waters, okay? So there's a premise there that the U.S. waters ought to be free from pollution, and that if you want to pollute waters, you need to justify this in some way through this nifty permitting system, which is really the main enforcement mechanism within the Clean Water Act, okay? It also required improved wastewater treatment by municipalities, and this, I think, was a very highly effective part of the Clean Water Act, and I can't show it here today, but some of the preliminary results from our NAQUA Cycle 3 trends work show very widespread decreases in ammonium, beginning in about the 1970s or 1980s. And I think, my interpretation is that this is really a result of wastewater treatment upgrades that were carried out in the 1970s that required secondary treatment and allowed time for organic material, et cetera, to oxidize within these wastewater treatment facilities. And as a result, the amount of ammonium showing up in surface waters had decreased fairly dramatically. The bill also recognized that water pollution arises from both point sources and non-point sources. But, within the law itself, it's sort of ironic. I mean, the non-point sources are, by definition, those places that are not regulated, okay? So even though it recognized that pollution arises from these sources, it really didn't have any way to regulate them. And there were fairly large exceptions for municipal stormwater and agricultural runoff in that initial 1972 version of the Clean Water Act. Since then, there have been some fairly significant changes to U.S. water quality policy. In 1977, this Rural Clean Water Program was added to support agricultural best management practices. When this bill was originally passed, the vision was really a widespread program that helped farmers sort of nationwide implement best management practices. By the time this particular program actually got implemented in the 1980s, it had been sort of whittled down to more like a demonstration program that showed that best management practices could potentially work in a number of demonstration sites around the country. And that I think that original vision had not necessarily been recaptured in that. In 1987, there were fairly significant changes to the Clean Water Act under the Clean Water Act reauthorization. The NIPD's permitting requirements were extended to municipal stormwater. State block grants were ended in 1987 under the reauthorization, and instead were replaced with something called the State Clean Water Revolving Fund, okay, which was a different mechanism for supporting state initiatives to improve water quality. And there was also support for non-point-source pollution abatement in this Section 319H, okay? But I think it's really important to recognize that the funding that goes to Section 319H is still very small compared to what is in the overall State Clean Water Revolving Fund. And the latest figures I've seen is that it's on the order of about 10% of the overall funding. And most of it goes still towards point source abatement. More recently, there have been these really interesting developments in the Clean Water Act, and a lot of them have come from the Supreme Court. In 2001, there was a challenge to the Supreme Court by the Solid Waste Authority of Northern Cook County. This Solid Waste Authority was, if I remember correctly, they were using these isolated wetlands as places to put solid waste as landfill. And the Corps of Engineers told them that they needed to get a permit under the Clean Water Act. The Solid Waste Authority came back and said that because these were not navigable waters, they were not able to be regulated under the Clean Water Act. And the Supreme Court came back and agreed with them on this. In 2006, I think a very similar case, this Rapanos versus United States, was looking at some isolated wetlands that were being altered. I think in this case it was a developer, if I remember correctly. And it was a similar issue where there were some isolated wetlands that were being altered, and the developer sued to saying that the Clean Water Act did not apply to these particular wetlands. The Supreme Court did side with the plaintiffs in this particular case, but in the decision, there was this really interesting wording that any water body that had a significant nexus with navigable waters could be regulated under the Clean Water Act. And as far as I can tell, people spent the next couple of years trying to figure out what a significant nexus was. And this year, the EPA finally issued something called the Clean Water Rule, which clarified the statutory authority of the EPA under the Clean Water Act, and it reiterated that the EPA can regulate flowing waters as well as waters that are in the 100-year floodplain from flowing waters. I think that the original estimates say that about 60% of the surface freshwaters in the U.S. are covered under the Clean Water Act due to the Clean Water Rule. And it's hard for me to get like a good read on exactly what all of this means. I think that the environmental community is, moderately pleased with this, and the agricultural community is moderately displeased with this. But beyond that, it's hard for me to know exactly what all of this means. And I think we won't necessarily know until this plays out for a couple more years. Okay, so now I'm going to turn to some of the empirical data we've been looking at using long-term monitoring data within the USGS and some other sources as well, okay? So we focused on these basins located around the United States, and we were looking at long-term changes in nitrate in particular, okay? So if we just start with this present-day spatial pattern of nitrate concentration in these particular areas, you see this pattern that I think all of us are used to seeing, where the middle part of the country, especially in the upper Mississippi River Basin, where you have the most heavy agricultural presence, you also have the highest nitrate concentrations as well. And if you get outside of those areas, nitrate concentrations tend to be lower overall, with the exception of a couple of heavily populated areas in the eastern and western coastal areas of the U.S., okay? But one thing that's, I think, important to point out is that, historically, this spatial structure did not exist. And if we look at nitrate concentrations in these basins that we are interested in, historically, they did not necessarily follow this same spatial pattern. The blue squares show places where we could calculate a mean flow-weighted nitrate concentration before 1940 for these particular basins. And the blue squares show that there's a fairly even distribution across the landscape of nitrate concentrations, okay? Even by the beginning of what I was calling the growth era, you start to see a little bit of spatial structure developing, but not to the same extent as what we see in more modern records. By the end of that growth era, this period 1975 to 1985, this spatial structure that we have come to recognize was really beginning to form extremely strongly in these particular basins. And then in the modern records, this more recent, say, early 21st century records, the spatial structure exists and it remains and is something that I think all of us are used to seeing, okay? So historically, that did not necessarily exist, and it's something that really emerged during this growth era, this middle part of the 20th century. I showed this figure earlier, and again, it's showing individual basins now, looking at temporal trends in nitrate during the period 1945 to 1980. Most sites that we looked at, 14 out of the 22 sites, had positive nitrate trends during that period, and only one basin had a negative trend over that time period. Now, if we look in the more recent records, 1980 to 2008, we see something a little bit different. Now we're seeing that we only really have a positive trend in the St. Lawrence River Basin, and instead, most of these other places have no discernible trend by the techniques we are using for this particular analysis, and we have negative trends in a few places that are not nearly as strong as the original increases we were seeing in a lot of those basins, okay? And so, during the middle part of the 20th century, we had these increases, and since then, it's been relatively level and has not come down, I think, the way we had maybe hoped it would after passage of the Clean Water Act. And if we look at the overall trends from 1945 to 2008, so this is taking the whole record now, you see that you find these positive trends that largely correlate with the positive trends that were occurring in the middle part of the 20th century, okay? And so overall, you have this story where U.S. rivers were increasing in nitrate concentration during the middle part of the 20th century, and since then, there's been more or less a leveling of nitrate concentrations, but not really the widespread decreases that we had seen, for example, with ammonium. Now, again, I can't show this here, but the preliminary results from the NACWA Cycle 3 trend analysis, which include hundreds of sites around the country, I think largely confirm this overall finding. And if we go back to trends from the 1970s or 1980s, what we find is that in some places it's increasing, in some places it's decreasing, but in a lot of places the overall changes are quite small. And so that if you look at all of the sites as a population, the mean or the median of that population is pretty close to zero, okay? And so, there's a lot more to be learned, I think, from the places where nitrate may be increasing or decreasing. But overall, I think the story is relatively solid that the overall effect has been more or less stagnant nitrate concentrations in many parts of the United States. Okay, I'd like to make one last point here, and that is just sort of emphasizing how the relationship between nitrogen inputs and agriculture has changed over these two time periods as well, okay? So now I'm focusing on this middle part of the 20th century, again, the growth era, And there's a very strong correlation between increases in fertilizer and livestock nitrogen usage and the ability to grow more agricultural products in those particular basins, okay? And we see, this very strong correlation, and it's also important to point out that many of the basins we studied were showing increases in nitrate, which is why they have these dark blue circles in there, okay? And the more recent time period, now we're looking at the squares, what we found is that this link between increased fertilizer usage and increased agricultural production has been weakened to some extent, okay? And so the agricultural system in the United States is maybe not quite as reliant as it had been on increasing fertilizer usage of nitrogen in these basins, okay? And it's been able to achieve increases in agricultural production in other ways, okay? But the important point here is that, even though the nitrogen that's added to these farm fields seems to be going into crops more so than into waste products or, essentially what turns into water quality problems later on, we're not seeing widespread decreases in nitrate in these places where the management has gotten better. And so these squares are this light blue color, okay? And the few places we have seen decreases in nitrate tend to be places where there's less agricultural activity or they're not as heavily agricultural overall, okay? So just to recap, I kind of walked us through, very briefly the history of water quality in the U.S. and these kind of major time periods and how the perceptions of water quality have changed over time as well as our response to those. And then I followed up with some empirical analysis of nitrogen trends in U.S. rivers and was looking at the fact that a lot of the increases in nitrate occurred during the middle part of the 20th century, and since then there's been a leveling, but not really the wholesale decreases like we saw for other constituents like ammonium. Okay, a lot of what I talked about today has been published in publications associated with the Century of Trends project, and you can find those at my professional profile at the USGS, and they're also on the USGS Publications Warehouse if you know how to use that, okay?